Hello friends, welcome to PharmaChem Insights. Today's topic is thin layer chromatography, that is TLC. In this video we are going to learn what is TLC, how to develop a TLC plate and its applications. So let's get started. What is TLC? TLC is a simple yet powerful technique used to separate and identify compounds in a mixture. It's widely used in chemistry labs for tasks like analyzing reaction mixtures, checking the purity of substances, or even identifying unknown compounds. Now let us see how to develop a TLC plate. Following is the list of the materials required to develop a TLC plate. First is TLC plate. You can see the image on right hand side. It is a thin layer about 0.2 mm thick of adsorbent such as silica gel or alumina spread over a glass plate act as the stationary phase. The plate is called the TLC plate or chrome plate. Second is capillary tubes. Third is developing chamber. Fourth is solvent or solvent mixture, also called as eluent. Fifth is UV lamp for visualization of spots. Sixth is pencil, ruler and forceps. Now let us see how to spot the sample. So you can see the image on the right hand side. Draw a line with a pencil about 1 cm from the bottom of the plate. This is our baseline. Then spot the plate using capillary tube. Spot 2-3 times to load enough concentration of sample. Make sure to get a concentrated spot but do not spread the spot. Now put a small amount of solvent in a developing chamber. The solvent should be just enough to cover the bottom of the plate but not the sample spots. You can see the image on the right hand side for your understanding. Now place the spotted TLC plate in the developing chamber leaning against the wall. Now solvent will begin to rise up the plate due to capillary action. It will drag the components with it. As the components move across the plate, they will interact with the hydroxyl groups in the silica to differing degrees. You can see the image on the right hand side of compound A and B. A substance that has polar functional group or a strong net dipole will interact significantly with stationary phase. This will cause it to move more slowly along the plate, almost as through the interactions. You can see the image on the right hand side. Compound B with the red spot is polar. A substance that is largely non-polar will not interact very well with the stationary phase and will move instead along with the plate very close to the solvent front. We can say that this substance is weakly adsorbed to the stationary phase, moves with the solvent close to the top. You can see the image on the right hand side. Compound A with blue color spot is non-polar. Now remove the plate and mark the solvent line with a pencil and then let the plate dry completely. Now let us see how to visualize the results. It is possible that the components are visible in TLC plate, but sometimes this is typically not the case. Often the plate is kept under a UV lamp to visualize the spots, as certain functional groups in organic compound interact with this wavelength and glow under this light. Sometimes chemical stains or other visualization techniques are used depending on the compounds being analyzed. You can see the image on the right hand side of UV cabinet, and below that image there is an image of TLC plate representing the spots which you can see when you keep these plates under this UV cabinet. Simply trace these spots. Now let us see how to analyze the results. Measuring RF, that is retention factor. Retention factor for a particular spot or compound represents the distance traveled by a particular substance as a function of the distance traveled by the solvent front. Here is the formula: Rf is equal to distance traveled by substance divided by distance traveled by solvent. You can see the image on the right hand side. A represents distance traveled by substance and B represents distance traveled by solvent. So that is Rf is equal to A by B. Now let us see the applications of TLC. First is in drug manufacturing, TLC is often used to ensure the purity of compounds before they are used in medications. Another application is to select a solvent system for column chromatography. It helps to find out a solvent system that maximizes the distance between two components on developing plate. This will best enable us to separate them in a column. Another application of TLC that it is used to monitor the reaction. It is very common application that you might have seen in your lab. In image 1, when you spot the reaction mixture, a single spot of reactant is seen as reaction is just started. In image 2, you can see two spots, one of reactant and other of product. It shows that the reaction is in progress. Some amount of reactant has been converted to product. In image 3, you can see a single spot of product, which shows that all the reactant has been converted to product, that is, the reaction is complete. Conclusion. So, to sum it up, thin layer chromatography is a versatile and straightforward method for separating and analyzing mixtures. Thank you. If you found this video helpful, give it a thumbs up and don't forget to subscribe for more chemistry content. If you have any questions or suggestions for future videos, drop them in the comments below. Again, thank you. Please like and subscribe my videos and also show your support in the comment section, so I will get motivated to create more videos of this kind. Bye.